Hello everyone. Today we will discuss about stationary signals and non-stationary signals. From this diagram of a stationary signal, we can easily identify that here the following function is xt, which is the continuous signal, is represented by a formula which is cos 2 pi 10 t. Here, if we can generate a formula or a function by a signal which is known as a stationary signal. Stationary signals are constant in their space of parameters. In this section, we have amplitude and standard deviation over the time. Stationary signal is one whose long-term statistics don't change with the time. That means the statistics of the signal from 0 to 100 second is the same. From 200 it remaining same, 300, 400, 500 and so on. If we go to the infinity number, that then the function of generating this signal will be remaining as the same, is known as the stationary signals. In non-stationary signal, the signal parameters like as amplitude and standard deviation of signals are not constant over the time. That means here from 0 to 200 second the frequency is in a level, from 200 to 400 the frequency changes, and from 600 to so on the frequency is changing continuously. That is why the formula cannot generate a single output as like as a stationary signal. That's why the non-stationary signal is different from the stationary signal. Here the frequency changes from time to time, and in a stationary signal the frequency and all other components remain the same over the time. Now, in the signal basics, we need to know some statistical time, which are mean, standard deviation, variation, covariance, correlation, skewness, Courtsies, etc. We all know what is the mean. Mean is the summation of all those values divided by the number of the value. Now standard deviation is denoted as SD. Here the formula is like this one. Here xi is the incremental value. Suppose we have x0 is the position of 1, x1 is denoted as the value 2. It will go as the index number, which is denoted as xi, and x bar is the mean value, and here n minus 1 means the total countable number minus 1. This question is very important, why we are using n minus 1 instead of n. Here we will discuss about the variance. Variance is none, just only the SD. We have the formula which looks like this, and for the variance it is just the square of the standard deviation. That means the standard deviation square is the variance. Now the covariance. Covariance denoted the how two variables are related, and in this section we have formula which looks like this. Here if the points goes from hither to thither, that means left to the right, then it will move as the large positive covariance, and it moves from the right to left, it will denote as the large negative covariance. And if the diagram looks like this one, then it will the near to zero covariance. Correlation is also quite similar to the covariance section. This one is the diagram for positive, negative and no correlation, and this is the formula of correlation. Skewness is the measure of the symmetry, or more precisely the lack of symmetry. Skewness tells you the amount and direction of the skewness. In this diagram we can see that if the skewness is in the middle, then it will in the symmetric distribution where the mean, median and mode are in the same manner. But in the positive skewness, the skewness moves to the left side where the mean, median and mode looks like this, and in the negative section the mean, median, mode will move to the right hand. Here we have the formula to know about the skewness, and this is the main formula of denoting skewness. Courtsies. Courtsies tells you how tall and sharp the central peak is. Here we have the central peak. In this section, if it is positive courtsies, the length will be very high. If it is the negative one, it will low than the normal distribution section. And this one is the formula of denoting the courtsies. Lastly, we have discussed about e-vectors and eigenvalues. Eigenvectors and eigenvalues are a matrix may can act certain vectors by changing only their magnitude and leveling their direction unchanged. Those vectors are eigenvectors of the matrix, and matrix acts on an eigenvector by multiplying the magnitudes by its factor, which is positive if its direction is unchanged and negative if its direction is reserved. The factor is e-value. That means here the magnitude and the leveling is known as e-variance, and e-value is just the factor we need to calculate in the eigenvector. So that's for today. Thank you.